with your work, which I'm sure you'll share in a moment or so?
Well, I think the most exciting thing is that I'm, in addition to my academic work, I do a lot of work with startup companies, and that's fantastic. And there's so much more, evolution to them. They're moving up from sort of the early stage to a later stage. But it's exciting for me to see that the larger players are coming in now too. The insurance carriers are funding research programs and validation studies.
Yeah.
The medical device companies and the pharma companies are starting to engage. So to me, it's just sort of fun to see it. I guess I feel like we're at a new stage, that somehow we went through the early adopter stage, and now the challenge is, as Brendan was mentioned earlier, it's more, we don't need to show the science behind what we're doing, although there's more work to be done there. But we do now need to work out the business model, the way to have it come into a clinic, but without being disruptive. If it's going to take more time, or if it's going to cause more paperwork for a clinician, then it's not going to go anyplace. But if we can, in addition to helping patients, help the medical ecosystem reduce its costs and save time, then we'll go someplace.
It makes sense. I think I asked the question to Brandon specifically about reimbursement, tariffs, which is the kind of I guess, the next step. I think we've got enough body of evidence now to show the benefits, and your work, of course, has been outstanding in that sense. But it's a question of how we negotiate. In the UK, for example, we do have a tariff for innovation now. So you can prescribe an app, for example, get reimbursed, but it has to go through a kind of committee to ensure that there's money available for that. So we are seeing a change in people's ideology, and also using actually paying for the tech rather than medicine itself. So it'd be interesting what happens. And Brendan spoke about the FDA. We're now kind of thinking around this whole concept, right?
Yeah. So do we have an audience now, or is it just you and I?
No, we've got an audience. There's a few people there who are waiting. So
Great.
I'm just trying to, we should start, or whether we should just wait until 6. I mean, two minds about what we should be doing, actually. Jean-Philippe, I'll text Jean-Philippe, see what he wants us to do, and then we can make plans one way or the other. Actually, let me ask the attendees. The attendees, can you just let me know whether you want to start now, then we can just get on with it? I think that would be sensible, or whether you'd wait until 6 o'clock. I'm in your hands, attendees. Just put in the chat for me if you can.
I think we should probably wait.
Harry says go. Okay, now I think they're all going to say go. Okay, but I'm going to go with with Harry and David Martinez. I think we should make a start. So Walter, it's great to have you here, and I'm really excited by the talks. Obviously, I followed you widely, and you've been the kind of, I guess, the person who's been doing this for the longest for all of us, and set the standards, and also set the vision for many of us in VR. So please carry on. I'd love to hear about your thoughts around your work and your vision.
Well, I do have a slide presentation that I could start with. Let me give a bit of a preamble that what I've missed is the opportunity to hear what some of the other presenters have provided, because I had some other obligations this morning. So there may be some redundancy. On the other hand, I think that it's such a large zone of information that perhaps some redundancy is a good thing. We all have our own vantage point for the potential of this emerging technology, and I think my vantage point is one of both a scientist who's looking at the data behind what we're doing, but also a person who's had experience in medical product development and business. So I have a vantage point that I think is maybe a little bit more biased towards what works and how can we get it out there, as opposed to what's the best way to do further research. I'm much along the lines that we just talked about earlier, and that Brendan highlighted. the opportunity, I think right now is to just sort of move forward. In many cases, we've known for more than a decade the power of the technology, and we've just been waiting for it to become affordable and to become more comfortable to use. Yes, we do need to figure out the economics of bringing it forward, but I think the price points now are such that the cost of a pretty robust VR system is less than the cost of a smartphone. So there has to be a way that we can start migrating it out there. And again, I think we have to be sensitive to reaching underserved populations, make sure we're not bringing out a new technology that's going to only be accessible by the elite. But I think we're ready to do that. So why don't I start with my my spiel, my presentation, and then we can maybe have a bit of time for questions afterwards.
Lovely. Thank you.
Okay. So. Okay, can you see my my slides?
We can see the slides, thanks.
Fantastic. Okay, well, I'm going to talk not just about medical virtual reality, but also how it interdigitates with some of the other emerging and confluent technologies such as biosensing and machine learning and some of the other emerging technologies that support it. I'll give a bit of an overview. To start with, let's see here. Okay, so I'll give a bit of an overview of what's going on in digital health in general. I'm going to talk about emerging and confluent technologies. I'm going to give an overall landscape of the technologies. I think the people who are listening to this talk now, they probably know that all too well, but it's worth just taking a brief look at the pace of evolution. My background is that of a neuroscientist, so I'm going to talk about some of the reasons that VR and AR technology have such impact in the clinical zone. And talk a little bit about the history of VR because it does have some relevance to where we are now. I'll give some examples of where I see there being some movement forward. And then I'll talk a little bit about how things might be in the near future. Excuse me a second, I'm having a little bit of trouble advancing. A little bit about me. My center of gravity right now is at the Stanford University Virtual Human Interaction Lab. I also spent some time, I'm sorry, I have a little bit of trouble with the controls here. Okay, I've got it now. I also spent a lot of time with the National Mental Health Innovation Center at the University of Colorado, where we have a focus on exploring how VR and AR technology can make a difference in mental health care. I previously had been a director at the Stanford University Center on Longevity of the Mind Division, and made me very conscious of the fact that we have a looming healthcare crisis that I think could be much more troublesome and much more economically significant than the current COVID pandemic, as surprising as that may be. But if we just do the math and look at the existing demographics, it's not a matter of theory. If we just take the existing demographics and add 15, 20 years, we can see that our population is going to be top heavy, that we will have a larger percentage of people who are in their 70s and 80s and 90s with a higher proportion of expensive and troublesome diseases such as Alzheimer's and other neurodegenerative diseases, and not enough informal caregivers, family members, et cetera, to help support that aging population. So the only way out is by leveraging technology. And that's one of the reasons, in addition to my academic work, I spent a lot of time working with some very exciting medical VR, AR product development companies, hospital networks, healthcare networks, and medical device companies, trying to help move the technology out from the academic research lab and into use. And by way of disclosure, here is a list of some of the groups that I am currently working with. I'm very excited about my affiliation with these groups. There's amazing things going on. So the context of all this work is the digital health revolution. We're seeing a real shift of how medicine is deployed. It's even more true now in the times of COVID, but the slide, I've been using it for several years. So it's part of the description of a trend that's been underway for a while, leveraging mobile health technology, better analytics, better sensor technology, but shifting the center of care from the clinic and the hospital, although there are some things that we can only do in a clinic or hospital, but shifting the locus of care to the patient and then giving more agency to the patient in their own healthcare. And that's one of the biggest trends that is part of the digital health revolution, is shifting the center of care to the patient and giving agency to the patient. I should also say I'm looking forward to the time where we don't say digital health, that we just say health and healthcare. Right now, we tend to make a separate description of it because it is a new emerging technology that is worthy of further dialogue and validation. But really, to me, soon it will just be part of healthcare. We won't make that artificial distinction of saying digital health technology. It's really the full stack of healthcare that is being impacted by the digital health technology trend, promoting better health and wellness, preventative health, much more objective assessments, improved training, improved clinical interventions, new ways to facilitate patient adherence, and ways to reach underserved populations. The whole stack of healthcare is being impacted by the digital healthcare revolution. As you know, every medical device in the last 10 years has shifted and moved from a handwritten analog world to the ability to interface almost all our measurement technologies to a digital health network. We're entering also, because of the consumer electronics companies moving into this arena, the era of medical wearables and hearables, devices that we can wear as on our wrist or as a ring on our finger, or something that we're wearing as part of our headphones, or a headband to wear at night to do a complete sleep hypnogram. It's really exciting, the reduction in costs and the ease of use that the consumer electronic companies have brought us in terms of medical measurement technology. And it's not just our physical parameters that we're capturing now. We're coming up with new ways to capture our cognitive and our emotional states. We can collect data passively from our smartphones that are an indication of brain health. We can use voice analytics as a biomarker for anxiety and depression. We can capture facial expressions and also use them as a marker of cognitive or emotional states. And we can also measure very adroitly some of the movements that we do as we use our technology. And these micro movements can be decomposed to also give us a sense of a score that relates to our cognitive and emotional health. All this data, of course, is being accumulated in cloud-based analytical systems, and ideally with proper attention to personal health-related information and protection of that information. We're evolving this really robust system that allows us to have on one arm patient-facing applications with virtual reality systems, tablets, cell phone technology, where we can push reminders, do better assessments, have people participate in a group interaction, connecting people. On the other hand, we also have analytics in the middle and dashboards at the other end, where clinicians can monitor not just an individual patient, but also the overall population health analytics. And health administrators can also look at the economics of patient care and better evolve precision medicine approaches to improve the efficiency of the system. So as we accumulate more and more data in these very powerful cloud-based systems and start using better analytics, we'll be getting much more sophisticated at refining our clinical protocols. And let me talk briefly about some of the emerging and confluent technologies that are going along with this revolution. Of course, with edge computing and 5G connections, we'll be able to have lighter weight and more high resolution AR and VR display technology. We can currently do earlier, we'd asked Brendan about how we felt about multi-user VR systems. Well, we're now approaching the point where we can do real-time cloud-based rendering of these multi-user VR experiences. And it allows us to push very robust VR environments, not just to those people who have a computer with a great graphics chip or a gaming computer with a great graphics card, because the ability to do cloud-based rendering and low latency networks and edge computing, we can push great, robust multi-user VR experiences to VR display systems without having to have a lot of processing at the local site. So we'll have lighter weight, less expensive display technology, and more robust interactive multi-user VR worlds, which I think is really important. One of the challenges that we've had with current VR systems is that they're sort of lonely. It's usually just one user interacting with either a 360 video or with a computer-generated world, but very rarely with other people in a robust way. So it's fantastic to see these the affordances that are allowed by better 5G connectivity. And of course, with machine learning, we can do better analytics and do better predictive modeling. We're also seeing the evolution of the digital twin paradigm, migrating over from what we've done to manage very expensive machinery in factories. We're now taking this paradigm of creating a digital twin and moving it over to healthcare. And this allows us to combine all the information we might have about a patient, their genetic information, their history and imaging, the data we have from their wearable sensors, and build a model of an individual and use that model as a way to do better predictive analytics and better prescription precision healthcare. And of course, the other confluent technology that's contributing to where things are right now is the evolution of sensor technology. We're moving to the Internet of Things, where sensors are embedded ubiquitously, allowing us to collect a large amount of information about how we interact with our world and how we interact with our technology. There's also been some shifts in our culture. We're now much more comfortable with the whole online world where we're connected all the time. It's sometimes a bit aggravating to always feel that we're connected, and it's hard to escape from that feeling of being connected, but it's here. And the good news is that we can leverage it to provide better healthcare. We're also getting better in terms of VR and AR technology with better avatars. We now can use voice analytics and webcam recognition of facial expressions to empower our avatars to be sensitive to us and to adapt their behavior to match our behavior. We're also better at imbuing the avatars with better nonverbal communication, better body language, better facial expressions. And the graphics are getting better, of course, for our avatars too, where we can map facial expressions and voice tones captured from us to our avatars. And that's going to allow us to be on the other side of the uncanny valley and have much more robust, believable avatars to be part of our multi-user virtual world. The other trend is that, and a lot of this has been empowered with the response to COVID, is that we're shifting where we do clinical testing away from the clinical lab. We're now coming up with rapid testing of course, for COVID, but also for flu A, flu B, for sexually transmitted diseases, urinary tract infections, biomarkers of stress and inflammatory diseases. This allows us to shift the power of the clinical diagnostic lab to where the individual is located. And that's, again, part of allowing us to develop sort of a home health hub that will allow us to also complement it with a VR system as part of better assessments and better interventions. And of course, the evolution of blockchain and other systems like blockchain to help us protect our data is going to be really, really key. and control access. Okay, I think I'm going to pause for a moment and catch our breath. I see we're coming up on the top of the hour. Is the plan still to just continue with my presentation, or should we wait for a few more people to join us as we approach the regular start time?
I think we should carry on. I think, and they'll join us over the course of time, I think, Walter.
Okay. All right. Well, I don't have to tell this group some of the surge forward that we've seen in VR, AR, and MR technology. And as Brendan mentioned earlier, in the medical arena, the FDA is promoting the term of medical extended reality. And I think that we're still juggling with some of the terms. You'll hear me through the rest of my presentation. I'll probably use the term VR more than I use anything else. And from my viewpoint, I view it as a spectrum of immersion, that with extended reality technologies, we have some that are fully immersive. We have some which are merging the real world with the digital world, mixed reality or augmented reality technology. I think the distinction is somewhat arbitrary right now, that we'll start seeing things emerge, and probably there'll be more evolutions of our terminology as we move forward. I remember when the personal computer revolution started and the internet got started, how there was this feeling that it was a shift in how we were going to be interacting with each other, how we were going to be interacting with technology. And I think the same order of magnitude shift is in process right now. It is my belief that extended reality technologies will really be the next platform, not just for how we work as it moves to the enterprise, but also how we're connecting to other people, how we're going to be entertaining and socializing. It's just beginning, but I think if we project out 10 years, we'll start seeing more ubiquitous use of VR for all aspects of our life. As you know, every technology company has invested a significant amount of resources building out VR and AR systems, and it's just gaining momentum. I'm often asked, well, why is this? What is the unique advantage of extended reality technology? And the answer is pretty simple. There's things we can do with extended reality technology that we otherwise cannot do. It's a much more intuitive way of interacting with information or with other people. We escaped the constraints of Cartesian coordinates and move into a more 3D spatial way of communicating information and our own unique way of expressing ourselves. We can slow down time, speed up time, go places that we otherwise could not go, of course. But I think most importantly is it allows us to come up with a deeply personal relationship to information. And this allows us to create experiences for individuals that are customized to the individual. And I'll talk a little bit more about some of the trends that are going on with technology that allows us to adjust the speed of the information that we're providing to people, the speed of the world based on cognitive load. Now, people have said that VR and AR technology has been slow to take off. But if you look at the rate of adoption for some other technology evolutions, VR and AR are actually evolving at a steeper slope than we saw for the adoption of color television or the personal computer, or even the internet and mobile phone technology. We're really taking off at quite a rapid rate when you look at the broader picture. And of course, the analysts are projecting that we'll see adoption in the next 3 years based on ordering of parts, etc. They're projecting that there'll be more than 30 million users using VR and AR technology, and within 6 years, 70 million users. And it's really all aspects of our life that are being disrupted. And of course, the theme for this session is on healthcare. And again, it's really the full stack of healthcare that's being profoundly affected by the technology. Health and wellness, assessments, training, clinical interventions, ways to facilitate adherence, and ways to reach underserved populations. When I look around and look at what sectors of medicine have we seen VR and AR being applied, it's actually hard to find a sector that has not been impacted. There's when I composed this slide, I did some rough addition and came up with more than 200 medical AR and VR companies. I suspect that I'm off by a factor of at least 2. That there's probably more than 400 early stage and Series A stage companies that are active in this arena. And again, it's the full spectrum of healthcare that's being profoundly affected. What's exciting to me to help us move beyond that seed stage and Series A stage companies is that some of the larger players are starting to be very, very active in this arena. Just to name 2 hospitals out of many that are adopting VR and AR technology in a committed way, Oak Medical Center and Cedars-Sinai. Also, we're seeing insurance groups here in the US, like United Health Group, spending substantial resources to help understand and to research and to validate the power of VR and AR technology for healthcare. We're seeing technology companies like Hewlett Packard invest significantly in coming up with systems that collect and merge biosensing with VR and AR environments, and then large medical device companies like Penumbra investing heavily in developing clinical applications. So we're moving beyond that sort of early stage, early adopters to the second wave. So I'm going to shift gears a little bit and talk about my focus as a neuroscientist and my perspective on why VR is so powerful and how in the field of psychology, psychiatry, it's been used to help promote behavior change. Some of the earlier speakers also talked about this. One of the powerful aspects of immersive technologies is that they can activate changes in our brain by leveraging our brain's reward systems and the neuroplastic effects of that. We can shorten the feedback loop. We can show progress and create novelty and feelings of pleasure and reward by showing progress, achieving a goal. And we can also leverage our mirror neuron systems. This ability to engage the brain's reward systems is really critical. And a lot of what we see in some of the more useful VR, AR systems in medicine is when they listen to the lessons learned from our friends in the gaming industry and the entertainment industry about what motivates people. By promoting adherence and promoting engagement, we're able to promote change. And in particular, in the field of behavioral medicine, this is really key. In the area of using VR and AR for exposure therapy, we know that VR and AR is much more impactful than just imaginative or in vivo exposure. We can engage both the visual thalamus and the cortex, activating subcortical threat detection and other response pathways because of the ability for us to capture the visual field, the auditory field, and in some cases, we even have olfactory systems that can help stimulate the cognitive engagement of the individual. And it's very clear from the research that VR exposure therapy is much more effective than either imaginal exposure therapy or in vivo. And it's certainly much more convenient. If we do in vivo or imaginative therapy, we don't have the ability to standardize, we don't have the ability to monitor, and we can't provide a graduated exposure therapy experience. So VR gives us a number of affordances that we just can't get from other forms of exposure therapy as used in behavioral medicine. The other thing I view as a very powerful tool that we have is the ability for us to leverage mirror neurons. This is one example of a project we did at our lab here at Stanford, at the Stanford Virtual Human Interaction Lab, where we age progress avatars of Stanford undergraduates. And we did an experiment where we gave them cash. We There were two arms to the study. There were those students who got to know their future self and have a dialogue with the avatar of their future self, and there were those who did not. And the ones who got to know their future self, who connected with their future self, were the ones who put aside money towards retirement. And those that did not get connected to their future self had less of an impetus to do that. We've recreated and re-verified this phenomenon on other situations other than just economic, and have shown that we can create empathy for our future selves and promote things such as exercise or better nutrition by shortening the feedback loop and showing an individual how the choices they make have, instead of waiting months to see the effect of exercise, we can show your effect on exercise on your avatar almost immediately. The other way, in terms of neuroscience, that VR and AR systems have impact is the degree of engagement that they promote. We can give people agency and have to be actively involved in the therapeutic environment. We can give them an experience that maximizes their cognitive engagement. Again, we can provide feedback. We can shorten the feedback loop to show people the choices they make and the activities that they do, how they have immediate relevant feedback. We can motivate them by showing through dynamic interactions with VR system how their involvement can provide immediate rewards and progress. The other thing that I think is really powerful about VR and AR technology is we can bring in the power of groups. As we're getting better at multi-user VR systems, we can do team training. And of course, I think the impact of VR is that we can do things in a more cost-effective way, reach people without having to have transportation and the expense of going to a training center, a simulation center, for example. We can do it in a remote manner. The other thing I think is really powerful about VR and AR as applied to the healthcare system is that we can leverage the power of story. Medicine is very difficult. It's hard to be a patient. It's hard to, it's an arduous process, an arduous pathway. But we can leverage the power of story to help make it a little bit easier for the individual and put them on their own healthcare quest. My colleague Jeremy Bailenson wrote a book the title was VR Experience on Demand. And I think that's a very apt description. But I also think it can be story on demand, that we can create a narrative around an individual's healthcare journey. And that provides superior retention, it provides better understanding, we can create greater context and relevance. Again, we can engage people in their own healthcare process by having it be a healthcare quest motif, and we can make it more personally relevant. So I think we're still just exploring how we can apply the power of narrative stories to healthcare experiences, but VR and AR technology give us the ability to do that. So let me spend a little bit of time talking a little bit about how VR and AR technology has evolved over the years. I first got involved back in the mid to late 80s when the first general purpose commercially available VR systems became available. Back in the day, we had very uncomfortable head-mounted displays that were in computer systems that were incredibly expensive. We used a data glove to pick up and move around virtual objects. But we were able to do research, and I and my colleagues over the last 3 decades have worked very hard, focused our careers on understanding the power of VR and AR technology and moving the field forward. What's the point? Well, the point is that there actually is a pretty extensive library of research studies showing the pathways that medical VR, AR technology can go down, and where some of the blind alleys are, and also where some of the value is. Now, most of these studies are done with small sample size populations and need to be redone using current technology with larger sample sizes. But the point is that we do have indications of again, where the value is, what what directions are worth pursuing and which where some of the barriers might be and some of the challenges. So I often find, to my surprise, that many of the people who are developing medical VR technology now don't have this impression that VR has only been with us for 5 or 6 years, and don't take the trouble to go back and look at the body of research that we have that can help guide the way. So let me start by giving some, wait again to give some additional examples of how VR and AR is currently being used. And I'll start with training. It's really the full stack of medical training where we've seen fantastic systems evolve. Surgical skill training, of course, but more broader clinical skill training, interpersonal skills, how to interact with a patient in a effective manner or sensitive manner, specific use of equipment and tools one can study up right before doing a procedure, maybe get familiar with a particular piece of technology that one hasn't used before. We can also do team training, have groups practice how to work together. And an extended example of that is emergency response training, where at a hospital level or at a town level or a city level, or even at a larger state level, we can practice using simulations how to work as a group and manage a healthcare emergency. And of course, because we can look at things from a first-person point of view or a third-person point of view, we can use VR and AR technology to help facilitate empathy with patients as they go through their healthcare journey. There's a number of companies that have come up with some very profound procedures for teaching specific surgical procedures. And this is, of course, really useful for people in remote areas who may never have to do a particular procedure, but if an emergency comes up, they need to study up right away. And using VR and AR and having experts look over their shoulder can be extremely useful. So much of anatomy and physiology training requires being able to think in a three-dimensional manner, and VR and AR technology help with that tremendously. We can also have virtual patients that we can use for practicing clinical skill training, learning how to do a patient history in a dynamic user using avatars that have natural language processing capacity. And this can be incredibly important when one considers the need to be proficient at how to deliver bad news. All too often in medicine, we have to give news of a terminal illness to a patient or to the patient's family. Being able to learn that before one's on the job is critically important in order to, it's the sort of thing you want to get right and you want to be able to practice in advance. Moving on, one of the other areas that VR and AR technology will significantly impact healthcare is in the form of next generation assessments. So much of what we've been doing so far previously has been based on sensor measurements, but when it comes to the fields of psychiatry and psychology, we've often had to rely upon self-report and recollection and the patient's ability to describe their cognitive or emotional capacity. But we're now moving into an area where we can use VR and AR challenges as a way to more objectively create an assessment. We can use VR and AR to help us do better medical imaging reviews. We can do more robust neuropsychological assessments. Because of our ability to capture motion and strength using VR systems, we can better score functional measurements of activities of daily living. This will have a profound effect on physical medicine, OT, occupational therapy, and physical therapy. And then the field of behavioral medicine, psychology, and psychiatry, having new ways of doing assessments is going to be really critical. I'm excited by the concept of coming up with new ways of doing cognitive assessments that involve a standardized challenge. I would love to have, and I believe we will soon have, a library of virtual environments that can be used in a diverse, culturally diverse, age-appropriate, challenging environments to do some of our assessments in. So instead of having an individual self-report or fill in a form, we can challenge them in a standardized way and see and measure their responses, both behavioral responses, but also the psychophysiology of their reaction to a standardized stimulus. I'm sure many people recognize that image of standing on a high precipice. It's often used in research labs or at conferences to demonstrate the power of VR technology to create an emotional state. In this case, it's the state of anxiety over fear of heights. Brendan Spiegel has talked about how that was one of his first VR experiences. But what's the point? The point is that we can reproducibly create a cognitive state. And if we can create a state of fear or anxiety or other emotional states, we can help people learn the skills to manage those emotional states. And being able to use VR as a evocative mechanism is so key to doing better assessments and developing better interventions. I'm excited by the announcement a few weeks ago of the HP Omniset headset. And not just the fact that it has embedded sensors to capture pupillometry and heart rate and facial camera to capture facial expressions, but to me, more significantly, the machine learning-based software behind it to come up with a score of cognitive load. The fact that we can capture a score based on psychophysiological signals that indexes how someone is responding to the virtual environment, to me is so exciting because we can use that as part of the next generation of training tools, but also assessment technology for better neuropsychological assessments. One example of how this technology can be used is the work of my colleague Lee Williams at Stanford Healthcare. Lee runs a program at the Stanford Center for Precision Mental Health and Wellness. And one study that I'm particularly excited about was used as a way to use VR environments as part of a classification system to come up with better targeted interventions for anxiety and depression. The idea here is to come up with standardized challenges that can be used to measure the response of people to a standardized stimulus, their ability to exhibit cognitive control, manage feelings of negative affect or index measurements of positive affect, and contrast them among individuals. So in this study, what we did is we put a number of people who were going through a longitudinal study looking at depression and also weight management challenges. And we did the brain imaging, but we also collected response to a standardized virtual reality environment. We showed them some relaxing scenes, some emotionally challenging scenes, and also a cognitive control game. And to correlate their responses in the virtual environment with what we are seeing with in the neuroimaging systems. The idea here is to evolve a system that can be used at primary care to do a differential diagnosis and be able to send people down the proper treatment pathway to say, for this person, this type of medication might be the best way for them to go. For another person who is showing up with the same clinical symptoms, based on our assessments, this might be a better pathway for them to go, to identify different biotypes, to the precision medicine analytics, and using VR as part of that decision-making process. So let's push on and talk now about some of the examples of improved interventions that we see in medical VR and AR. I think you heard earlier from Rob Lewis about how VR and AR is being used as part of preoperative planning and image-guided surgery. I'm excited that Penumbra has moved in as a large medical device company specializing in neurotherapeutics, that they've put a tremendous amount of effort to come up with a really robust VR system for stroke and traumatic brain injury rehabilitation, both acute and post-acute. This allows us to have a new approach to physical medicine and rehabilitation. And again, by aggregating data and doing better analytics, we can come up with a more predictive model to come up with a precision medicine approach to help people go through the difficult process of recovering from a stroke or from a traumatic injury. I'm also very excited by some of the ways emerging VR and AR technology is going to make a big difference in the field of psychiatry, psychology, and behavioral medicine. As we're all aware, it's a difficult process to go through our mental health care system. It's backed up right now, and someone might make the very difficult decision to make a phone call and say, I'm having a problem with addictions, or I'm having a problem with depression, I'm having a problem with anxiety, and they're told they have to wait for months before they can have an appointment. By leveraging new technology, I think we can come up with both better diagnostic systems to be able to say who should be put at the front of the line and be seen right away, but also better systems that can be used to magnify. We just don't have enough caregivers right now in this field, and we can magnify their work by leveraging VR and AR technology. We've heard previously about how VR is being used as a way to help mitigate pain, both acutely and also chronically. We've been able to show that interactive virtual environments can significantly reduce pain and can be used to help reduce the reliance on narcotics in the hospital. This will also, I think, allow us to help reduce the number of people who are dependent on opiates moving forward. So again, not just acute pain distraction, but also distraction from uncomfortable procedures such as dialysis or chemotherapy, and then new ways to help people learn techniques to manage chronic pain. We've had decades of research showing the value of VR and AR technology to address problems such as post-traumatic stress disorder, phobias, and other anxiety disorders. Our ability to provide exposure therapy leveraging VR and AR technology is pretty exciting. Again, it gives us the ability to provide exposure therapy in a much more robust, but also much more controlled process where we can, instead of having it be reliant upon imagination, we can gradually take people in a controlled way, in a way to help teach them the skills to manage their learned anxiety, their learned fear response. And we can also use exposure therapy paradigms to help with managing addictions and problems with substance abuse. We can use exposure therapy and also scenarios to allow people to learn refusal skills, how to respond to peer pressure, for example, at a party or at a bar. And we can teach people situational confidence. Again, if we're just using people's imagination to evoke a feeling of craving, it doesn't go very far. But if we can create a craving in a context, we can help people learn the skills to manage and give them the confidence to do so. There's a very long list of where VR and AR technology has made a big difference in behavioral health care. Almost all aspects of psychiatry and psychology have seen some great applications developed. I talked earlier about phobias and post-traumatic stress, but also generalized anxiety disorder, tools to help people with psychosis, eating disorders, anger management, obsessive compulsive disorder, social anxiety disorder, depression, chronic pain, impairment, mild cognitive impairment, attention deficit disorder, autism spectrum disorder, a whole variety of really amazing ways to address a whole spectrum of problems in mental health care. Another exciting potential direction that I think needs to be further developed is using VR as a way to reduce anticipatory anxiety. We did a project at the Stanford Children's Hospital where we captured 360 video of the patient experience, starting in the parking lot, moving to the waiting room, going to the check-in area, moving to the preparation area, the operating room, the discharge area, and we green screened in as guides children who'd gone through the procedure before. And they served as guide to introduce the patient and their family members to what was going to go on and to meet some of the clinician. This reduces the anticipatory anxiety tremendously. So we can provide a VR headset to people weeks in advance before the procedure, so they can be familiar with the hospital layout, be familiar with what's going to happen, and be prepared psychologically for a potentially traumatic experience, and do the stress inoculation to reduce the anxiety behind that experience. We've also seen a lot of groups start moving into the field of applying VR for senior care. What I'm excited about is to start seeing the evolution of platforms that are used to address clinical problems. So not just something that's addressed to one specific problem, but something that can be used to address a variety of problems. And often in senior care, we see a number of comorbid conditions, chronic pain, problems with movement disorders, problems, cognitive problems, anxiety, depression, the need to promote adherence to medications. And with a platform approach, we can have one common user interface, one common way of approaching a problem, but that addresses a spectrum of different conditions. And moving on to the final zone that I want to talk about is how we can use VR to help with health and wellness, promote better behavior on the part of individuals, and promote exercise, help people address their stress, help them improve their mood, but outside of the clinical context, just general health and wellness applications. Again, I think one powerful way to do that is to create shorten the feedback loop by creating a way of having a dialogue with your future self in a variety of different incarnations. One could imagine that someone who is, for example, trying to cut back on their use of alcohol might set geofencing around their phone, so that if they go into a bar, their future self calls up and complains, saying, "Hey, I thought we talked about this. We agreed that you were going to cut back on your drinking, and here you are going into the bar at 2 in the afternoon." So there's a lot of power of using this ability to have a dialogue with an avatar as a way to motivate yourself to change your behavior. And of course, VR and AR technology allows us to reach out and provide clinical interventions in a telemedicine way. And again, it's the potential to have a platform that transcends not just a clinical intervention, but also extend over to help with health and wellness, to maybe provide a intervention at a hospital or at a clinic, but also go home with the patient for post-discharge follow-up. So this use of VR as a platform, I think, is really a powerful concept. So what are the constraints? What are the gating steps to adoption? Well, we still have to do a lot more research. Most of the validation studies that have already been conducted are on small sample sizes, and they're with technology that is maybe already obsolete. So we need to do more robust intervention. We need to do not just studies on how VR and AR technology provides clinical benefit, but also how does it affect the medical ecosystem? If it helps reduce healthcare costs, that's very important to understand. But if it makes the clinical ecosystem more complex, if there's more paperwork involved, or if clinicians have to spend their time making sure that batteries are charged, it's not going to go very far. So one of the things that needs to be done right now is to take some of these very powerful clinical assessment and intervention systems and make sure that they're optimized to fit into the clinical ecosystem in a way that reduces paperwork and reduces the time burden, and as well as providing better clinical care. Okay, so what are some of the trends that we can look to for the near future? Well, I think we're going to start seeing VR and AR as part of combination therapy, where one might be given a prescription for a medication, but one also might be given an app to use on one's head-mounted display, and maybe even provided with, as part of the prescription, a head-mounted display. so that we can have combination therapy, the medication when used in combination with a VR or AR clinical intervention. I think we'll start seeing better precision medicine models as we collect more and more data in the cloud, and again, ideally in a way that protects personal health information, but allows us to have the power of large data sets. I think we're going to start being able to use VR and AR technology as a way of managing patients between clinical visits. All too often right now, so much time goes by between the time a patient sees a clinician. If we have a telemedicine platform using VR and AR technology, we can not just provide interventions between visits, but also do assessments and use that as a way to look for flare-ups or problems and catch them in advance before they become a crisis. I think we'll start seeing more reliance on VR and AR for clinical skill training and credentialing. Right now at the Children's Hospital of LA, their residency program, all the new residents are required to go through pediatric resuscitation training before they're allowed to work in the pediatric emergency department. I think we'll start seeing more examples of that sort of requirement of simulations and training as part of credentialing. Right now, VR, as I mentioned earlier, covers a large spectrum of clinical zones, but there's a few that are having more activity than others. Pain, there's a lot of activity there, educational training, stroke and traumatic brain injury, surgical skill training, anxiety management. Those are some of the hot areas right now, but there's some relatively underdeveloped significant opportunities, such as helping with addictions, using VR and AR as teaching situational confidence and refusal skills, helping people on the autism spectrum recognize nonverbal communication and learn how to recognize their own behavior and how to recognize nonverbal emotional content in other people by magnifying it within a virtual environment and staircasing people to the point where they understand and recognize nonverbal communication in other people, just as an example. Improved cognitive assessments, new interventions for depression, using AR and VR as an interface to promote better support for people with disabilities. And we need to do more work in palliative care. So I mentioned at the beginning of my spiel that I am very concerned about the downstream healthcare crisis that we will see in 10 to 15 years involving an aging population. The good news is VR and AR is part of the evolution and revolution in digital healthcare. It does address a lot of the problems that we see in senior care. It can help address isolation and loneliness, acute and chronic pain, depression, neurorehabilitation, designing for disabilities. I think VR and AR technology will be a really effective tool to be used to address some of the challenges that we see emerging from an aging population, and I'm excited about that. One of the questions I often get asked is what's the impact of COVID on VR and AR? And what I'm seeing right now is that COVID-19 and the shift of funding and emphasis on telemedicine is propelling VR and AR systems to move forward. The regulatory barriers are dropping, also the conceptual barriers. We're getting more used to having the patient be at a separate location than the clinician. Investments are increasing. We're also putting a lot more emphasis on the importance of improved mental health care because of the stress and anxiety of the current pandemic. And we're seeing the evolution of systems like CleanBox that are used to disinfect our VR headsets. So I do want to point out the International Virtual Reality Health Association, a member association that has a focus on virtual reality in healthcare. And I'll summarize by saying that from my vantage point, we're at a very exciting point of departure. We've had 30 years of research and development underpinning where we are right now. Of course, with the reduction of cost and increased comfort of using today's VR systems. We're at a fantastic point where we can push it from the early adopters and the academic research arenas out to part of the clinical care ecosystem. It's really the full stack of healthcare that is seeing some fantastic VR, AR, and XR interventions. And I feel that we're poised to move into the mainstream. Okay, with that, I'll stop and pause to see if there's any questions.
Thank you very much, Dr. Walter. And you're definitely not Jean-Philippe. So sorry for that. We have this strange glitch with Zoom, and many people comes with my name. I don't know where to go. We will fix it for sure tomorrow, for tomorrow's session. But anyway, so thank you again for your time, your kindness, and we are very humbled to have you, not because I'm flattering, it's not my type, but I know you, I met you 2 years ago in Zurich, remember? The Chinese restaurant. And I learned so much each time. Yeah, that's why when we were thinking about, we were planning this event, one of the first names coming to our mind was you. And you are there, and thank you so much. I greatly appreciate your time. And what you said is very interesting, and I have many questions. So just to have your authorization, we have some attendees actually, they don't have they can't be on the scene. You accept them, do you accept that I put them on the scene and so they can ask directly some question to you?
Okay.
You agree that they come on, I would invite them for those who want to be to come on the scene. I will propose to anyone, because this is a rare occasion to have a real someone who really knows what is VR in medicine. And yeah, for me, it's a chance for everyone here to be online. And yeah, so I gave, we have few people staying actually, and now everyone is online. If you have some questions, feel free to ask. But my first question for you, Walter, is about this combination of pills and VR. I read somewhere that VR activates the same region in the brain, like nicotine or some drugs, okay? And I think that if we take VR plus some kind of, I don't know, mushroom or things like that, it could be very difficult to support, no? That's just a thinking. Do you understand my question, or it's lagging?
I do. Let me respond a couple of ways. I think one of the powers that we have with VR in clinical care is our ability to engage the patient. It's difficult to be a patient. It's a long process and with a lot of challenges, and often it's confusing. So yes, VR does stimulate the reward centers, the pleasure centers of our brain, and we can use that as a way to motivate people to come back and keep working on their problems, and also to learn to shift their behavior away from maybe some disadvantageous behaviors. I think it's also, the other thing you made me think of with your question is there's a lot of new therapies evolving that involve ketamine or psychedelics to treat some very difficult problems in mental health care, like depression or like post-traumatic stress. But those therapies that involve the prescription of ketamine or a psychedelic need to be supported by the right preparation for the experience and the right post-session integration. And one of the powerful things about VR technology is that we can use it to help people learn in advance, to reduce their anticipatory anxiety to understand what the experience is going to be like, maybe learn some skills such as diaphragmatic breathing to relax, or also just to understand a little bit more about how their brain is working and what the process of therapy will be. So I think we'll start seeing VR and AR technologies moving out, leveraging that brain's reward system that you talked about with dopamine, but also being supportive for other therapies, being part of the therapeutic process as an adjunct.
So the sensor coming into the headset actually, I don't know, for Facebook or mainly for Facebook. What you think about it? It should be public or should be stay in the professional area?
Well, I am concerned about, I think Facebook's decision to have VR, its Quest system, you're required to have a Facebook account. I think that's going to be incredibly problematic for medical VR and also for education. We can't ask a student or we can't ask a patient to set up a Facebook account just to get help, just to get education, just to get therapy. So I think what I'm seeing as a response is many of the other platforms that are made by other VR companies are going to see the medical product developers migrate to them as a response to Facebook's decision. I think the other part of your question was about the biosensors. I think right now, with almost any headset, we can do some biosensing in that we can get head movement and gaze direction. And that tells us something about attention and orientation, and it's a signal. But as we start putting more sensors into headsets, like Hewlett Packard has done with their Omniset headset, or if we, well, here's let's see, let me get it. It's here someplace. 1 second. Well, I'm not finding it, but there's a headband that is made by Interaxon that has a sensor module in it that has EEG and other biosensors that can be worn along with a head mount display. Or so I'm starting to see that sensors are being embedded in the system, but also used concurrently. And of course, there's other wearable sensors like that we can wear on our wrist or other parts of our body to collect data. I think it's this integration of psychophysiological data along with being able to capture gaze direction, pupillometry. It's going to be a very powerful way of doing better diagnostics and customizing the pace of VR interventions to the individual.
But it should stay in the hand of professional, or
oh, I see.
That's a problem about.
Yeah, I think it's a big problem. We have to keep our personal data personal. And I do worry about companies like Facebook. And it's not just in a clinical context. I think that we're getting better with machine learning at collecting data from online gaming, for example, about our voice tones, our movements, our behavior in these online things. And with better analytics, we could take data even outside of a medical context and use it to come up with a score for someone. And I think we need to come up with a new set of guidelines and rules to certainly protect medical data. Anything that's collected in a clinical context needs to be locked down, and the individual needs to have control of that information. But also, I think just general use of VR, the data that's collected there could be used with the right algorithm to come up with different medically related scores. And we don't have any regulations in place to protect that right now. And I think we really do need to.
And the question. So I have a question about there are some VR medical devices actually promoted on the internet. Some claims to be FDA approved. That makes sense, because if you look at the clearance that say they have, it's kind of just, I say I put a product, is not harmful, but it doesn't mean. And another thing is that, can we expect, can we pretend from today to, I don't know, 10 years even, have a VR device which could be medically correct? And let me tell it like that, precise, because of the precision is not there actually. Everything we try to put into the machine is very imprecise. So what I really want to hear from you is what you think about that. Is it too marketing?
Well, a couple things. One is, I think it's important to realize there's a difference between FDA registration and FDA clearance. And in one case, a company can register with the FDA. In another case, they've gone through different regulatory processes. And I think often some companies say they're FDA approved. And does it mean FDA registered? Does it mean FDA validated and cleared? There's, I think, an overuse of the terms. I think there's also a little bit of worry and concern on the part of some of the early stage startups that they're being careful to stay on the health and wellness side of things and not move into the clinical zone, because they're worried about the expense and they're worried about the hassle and time of going through the FDA regulatory process. I think that's probably a mistake. I think there's some things that really should just be on the health and wellness side of things, but I think there are some things that our colleagues in the VR arena are doing that will make a big difference in the clinical zone. And I don't think the FDA review process is as difficult as many people think it is. You can often receive what is called 510K substantial equivalence, where you can show that you're equivalent to some already established procedures. The FDA has set up its new digital health division, and I think it will make things a lot easier. So I think people need to be very careful and cautious of what's going on. Be careful about some of the claims that groups are making, but I also think it's important to not necessarily be afraid to go into the clinical area. It's very important that we move in, and it's not as hard as many people think it is to come up with the right level of regulatory approval.
Ferran, you have a question?
Yeah. First of all, thank you for this very insightful presentation, Dr. Walter. I actually reached you on LinkedIn as well to ask a few questions. Now it is the time, thanks to the organizers, to ask in person. So a little bit about ourselves. We had actually a session right before your session, and it was focusing on hand tracking. And we are a global academy creating VR AR advanced programs for different verticals. And it is very interesting. Actually, some of our students were on the call today, but I think they are now preparing for the next assignment, so they had to leave. But we have seen a lot of medical XR companies and universities attending to our classes on hand tracking and advanced physics-based interactions. So I see that on your slides that I think surgical skills training is directly fitting to that. We would like to talk more on that, because this is something that we are creating a master class a project-based masterclass based on vertical. So we have now our hand tracking masterclass is focusing on a virtual robotic arm, but the next step we would like to actually create something focusing on a medical use case, teaching advanced physics-based interactions, because what we have seen from the audience that is reaching to us, they have difficulty in having a not zero, but almost zero tolerance physics-based interactions, as Mohammed mentioned, that it is not easy in terms of the Unity skills, in terms of VR development skills. So what is the biggest problem or challenge on medical XR in terms of user interactions, hand interactions, even controller-based, physics-based interactions? So maybe we can even focus more on our modules on that and help medical XR companies to be upskilled through these courses.
Well, certainly coming up with better physics-based and biokinetic models, looking at the kinesiology is really important. There's a number of ways of tracking wrist and pronation, supination, the MP, the PIP, and the DIP joints of the finger.
Mm-hmm.
But I think really what is key to a good training system is something that is able to have a course of training learning management system behind it, combined with fantastic graphics and physics, and being able to do the right modeling of movement.
Mm-hmm.
But I also think what needs to happen is understanding what makes a good learning experience compared to one that's not a good learning experience. If you might want to look at the research of Dr. Carla Pugh, P-U-G-H.
Mm-hmm.
She's a colleague of mine at Stanford University. She studies very successful surgeons who have the best scores for successful surgeries, the ones that are training other students. And she studies how they hold their hands, what movements they make. She collects data about the time, all the data you can collect about head position, hand position, etc. And I don't want to try and describe the conclusions of her research. I would be doing her a disservice to try and summarize in a few sentences, the very robust work that she's doing. But I will say this: it's surprising what people think you need to learn. That there's some things that people learn to do the wrong way, because what's not brought to the surface is what's the best way to do something. It's often hard for a experienced surgeon for her to describe how she does something, but if you measure what a experienced surgeon does and then study it, you can find out the best pathway to get the best results. So I think you're taking the right approach by collecting the data in a precise way, coming up with the right models. But I think a layer on top of that is understanding for a particular project or a particular problem, what's the best pathway, and using that as your goalpost. And perhaps you're already doing that in your system, but I think that's the key thing, is to close the loop between what can we measure, what's the best pathway, and then how can we teach our students that pathway to give them the feedback they need and to learn at their own pace. There was a very interesting study done by Jeremy Bailenson, where he looked at student-teacher dyads, a pair, and he was able to use machine learning to see who was a good combination of teacher-student. That some students and teachers just aren't working well with each other for whatever reason, and others do work well with each other. So there needs to be a matching of the most appropriate teacher for the most, for the student who has a certain learning style. As one moves to VR-based learning with maybe an avatar who represents the teacher, Well, I think we need to study that. We need to study, okay, is it what makes a good educator as an avatar? Is it their body language? Is it their voice tone? Is it their facial expressions?
Mhm.
It's not just what they say and what the curriculum is, but
Yeah.
there's something behind that in terms of how it's said and how and what and some students learn differently than other students. So I think there's an opportunity to not just, it's great that you're doing work on the physics, the physical engine of modeling finger position, et cetera. But I also encourage you to look at the other end of what makes a good learning experience in terms of the teacher, student, and then also the measurement of a experienced surgeon, how that information can be conveyed most effectively to a learner.
Mhm.
So glad to hear about your work.
Great. I can share with you after the session. I mean, on our case, most of the reason that they are coming to us are universities or XR companies, because there are universities, maybe in your case the same situation happening, since they cannot use physical spaces anymore due to Corona, right? They want to bring all their medical curriculum to VR, right? And whenever they would like to create a physically lifelike interactions. And when I look at the level of interactions, even when I compare with entertainment, the interaction level with controller or with hand tracking is very primitive. And if it is in that level from a medical standpoint, when you teach this, it will not be impactful or useful enough to the student, right? Because you cannot even replicate I don't know, a very simple surgical operation in that tolerance and sensitivity level, right? So what we are trying to do is, of course, the medical subject matter experts, we can definitely bring more, but we help them how to use Unity, Unreal, and different toolkits out there to create. Of course, it needs a lot of physics and mathematics and geometry fundamentals. We are teaching them how to create these interactions with from scratch. So it's like a little bit an advanced course. That's why, I mean, most of the time the medical XR developers are joining. So, but I would like to hear more about that. I will share one of the experiences of our trainers, so it will give you a better idea. Thank you for the answer.
Thank you, Ferran, for that. This is very interesting, and bringing the knowledge from the enterprise or to the academics and so on. It's very interesting. So I know your time is precious, Walter. Again, thank you very much for being with us, teaching, schooling, and on the best level. To have a Stanford teacher at 20 hour in Switzerland is not common at all. So we feel very lucky for that. And so thank you again. Have a great day, and see you soon, maybe in physical.
Thank you for inviting me. Take care.
Thank you.
Yeah, thank you very much. So guys, thank you. See you tomorrow. We'll send you a new mail, and yeah, invite you see the quality of the speakers. We are on a very top quality, so it could be a good thing for everyone to see these guys. Bye. Have a great night. Bye.
Thank you. Bye. See you tomorrow.
Bye. See you tomorrow.